Hello everyone, my name is Matthew Kling, and today I'm going to talk to you about our SCM 345 case study with Intel, along with my colleagues and fellow team members Owen Larson, Kenny No, and Carolina Konarski. I know that many of you Intel professionals that visited us are actually graduates of the ASU supply chain program itself. And I'm sure you all remember a room called BA 460. BA 460 is the conference room, fourth floor of the BA building. It has your three whiteboards in the front. It has about 5 or 6 tables, depending on the day, full of students, and it has a professor sitting at the front. And in this room, they like to conduct every year the beer game. I'm sure you can remember the beer game, lots of crazy going abouts and trying to figure out demands in the bullwhip effect. But if you noticed, everything is done on pen and paper, and not a lot of it is collaborative, and a lot of it is done manually. So when I think about the Intel Interactive Whiteboard, this room gave me an idea. What we do is instead of BA 460, it becomes IWB 460. And in IWB 460, each table collaborates with the professor with their own beer game. In real time, you can see the bullwhip effect operates. You can see in real time how demand changes and how supply doesn't keep with and versa. And it can all be streamed to an Intel Interactive board illustrated by the professor to show the class the bullwhip effect in action, changes in demand, scores, and who is the top contributor of the classroom. Now, the reason interactive whiteboards exist is because of the Internet of Things. And I like this little comic here because it really shows you exactly what the Internet of Things is. Everything in your household will soon have their own chip, and it's going to be transferring data to a database. And with that data comes immense opportunity. In fact, data is the future itself. It's the future because everything that is connected together can submit real-time information through any sensor that can be used to compare values and make decisions on the fly. Intel seeks to move from a semiconductor industry. In addition, they want to become a data company. They want to be able to process data, and they want to be able to capture that data, and they want to get value from it. And they will get value from it through their devices, such as the interactive whiteboard.
As you all know, digital signage is a display that allows for interactive media experiences, and it is growing consistently and quickly. According to Intel, the digital signage market is expected to grow at an annual rate of 5.2%, forecasting over $30 billion in growth by 2023. We believe that as one of the largest and most innovative universities in the United States, Arizona State University will be the crucial first step into penetrating the international market setting by innovating and disruptive education delivery. Intel's interactive whiteboard is powered by the latest Intel Core processor while being displayed on a fast and responsive 4K monitor. The whiteboard is customized with the latest software to perfectly fit the needs of any education environment. Collaboration is easier than ever. The Arizona State University pilot program will deliver Intel's latest interactive whiteboards of the highest quality to classrooms, study rooms, dorms, faculty areas, and other common areas. It will allow students and instructors to collaborate information in real time, and it may be the first step before it is introduced into the professional world. Over the course of half a decade, a large majority of paper used on assignments have been phased out in favor of digital assignments and education tools. Even high schools and elementary schools are opting for digital media to deliver education in their classrooms. Students not only have access to their instructors' lecture notes, but are a click away from any kind of information available worldwide. Collaboration between students and instructors is also a key trend in the future of education. With the use of technology, inconsistencies that may have risen between students and instructors are becoming less of a worry. The trends mentioned not only facilitate the delivery of information to students, but also create an arms race with teachers. As new information is easily accessible and available, instructors need to find new ways to deliver and create new forms of educational value in order to stay relevant in the evolving digital landscape. The result is greater information, accessibility, and increased educational value. Since the world was impacted by the COVID-19 crisis, Educational institutions all over the country are now faced with the challenge of providing learning remotely, abruptly, and at a scale never before seen. Digital tools like Zoom or Skype that were underutilized before the crisis are now being adopted at a fanatic pace for institutions to adapt and deliver digital education. COVID-19 is proving how important new technology is for the future of education delivery. For the first time in hundreds of years, the future of education shows great uncertainty, and that is why Intel has an opportunity to be a first mover in the market.
This is our basic supply chain network. First, the components are manufactured by the suppliers, then are sent to the ODM where they manufacture the interactive whiteboard, and then they get shipped out to the customers, which in our case is ASU. We needed to figure out a way to select and compare suppliers in regards to their component costs, their quality rankings, and their capacity to handle demand. So we developed a tool that allowed us to change suppliers via a drop-down menu, and that made it much easier to do the comparisons. This also allowed us to determine whether or not we needed secondary suppliers for some of the components, because some of the higher quality suppliers cannot supply enough for the required demand. The ODM we selected was Eagle One. This is because of how much our team valued the quality in our products, and this is especially important to ensure that our pilot program takes off. The cost analysis tool we developed assisted us in figuring out the profit margins for the whiteboard as well as the costs associated with the production and shipping of the whiteboard. The total assembly cost per whiteboard was about $9,382 and about $47 million for 5,000 whiteboards. This is based off on us selecting the highest quality supplier for each component for the whiteboard. With the use of our analytic tools we developed, we were able to determine the best suppliers to use for each component. This also allowed us to select some secondary suppliers for the touchscreen and camera because the primary suppliers could not handle the demand, and we wanted to ensure that we delivered all the whiteboards on time with the greatest quality. Although the secondary suppliers may hinder our overall quality in the short run, it gives us a nice flexible schedule we can work with to handle the increased demand in the because Intel is a first mover in the digital whiteboard market, quality is Intel's competitive advantage.
Our execution plan is shown as follows. The Gantt chart orders the tasks our team has deemed to be essential to complete the pilot, as well as the number of days it will take to complete each task. In the table below, you can see the dates used for each phase of the plan. The length of tasks and the days associated with them were chosen to keep the project and team on track to meet ASU's monthly demand. To meet the demand, we have created a production that will churn out 280 whiteboards on February 1st, building inventory of 1,400 whiteboards prior to the initial delivery on August 1st. We built this stock on the front end to improve our customer service by creating flexibility, minimizing the impact of any damages or defects with the quick response of replacement parts or whiteboards. To keep this flexibility while meeting the pilot project's demand, new purchase orders will be sent out a month before increasing production from 280 to 300. Shown here is the schedule for final delivery quantities to ASU and remaining inventory left at our ODM. Our production schedule created 1,400 whiteboards in inventory prior to our first delivery date to ASU, and will ramp up production thereafter to 300 whiteboards a month. The 1,400 whiteboards in stock will be reduced to 610 following the August 1st delivery to ASU, with the addition of 300 more in production to be completed prior to the second delivery on September 1st. Should ASU have any issues with damage or defective product, the remaining inventory has enough flexibility to expedite replacement parts or whiteboards to ensure customer satisfaction.
As you can see, the supply chain we just demonstrated to you fits our competitive and Intel's competitive qualities of flexibility, quality, and the ability to produce the massive products that we need. We want to especially thank the professionals at Intel for actually gifting us this opportunity to do this case study. And we wanted to thank our professor, Mrs. Kane, for working with Intel, getting us this opportunity as well. We hope you enjoyed having our presentation played for you, and we can't wait to answer your questions on Thursday.